All right, so we are back. Model Monday, the Milwaukee Makerspace. We are going to finish our scissor mechanism today. So, last week we started this scissor mechanism. I'm sorry, 2 weeks ago we started this scissor mechanism. And then we had a 1 week break for America. America, 2 thumbs up. That's what I give it. All right. So, we're going to finish our scissor mechanism today. I had an epiphany and a change of total pivot. We're having a total pivot. We were going to put little teeth chompers at the end of our scissor mechanism. And we've had a small streak of dog-related projects. So we are, instead of a little chomper head, we're going to make a end that will be sufficient to pick up a tennis ball. So when you're at the park with your best friend, just having a fetch, you don't have to bend over like a chump. You can use the power of modern mechanics. All right, so where we left off, we had separated our scissors into their own components. That is important because in order to actually make this move later, we need to have individual components as part of this scissor mechanism. And I'm going to go right to the head, right to the picker-upper, I think, is where we're going to start here. So we really want to be working inside of the component that we want our part to live in right now. So we have 2 components here at the end. The component that makes up this part of the scissor and the component that makes up this part of the scissor. And I want to change my active component to be the component that I want to make my parts inside of. If that makes any sense at all. English is hard. Words are hard. So in order to figure that out, what I do is I click on the item in my drawing view, and then I can look over in my browser and see the thing that is underlined. So because I've got that scissor, the scissor that points upward highlighted, I know that this is the correct component that I want to make my active component. So I'll click on the little radio button next to that component. And then I'll just use the little triangle to spin it down so I can see that component's contents. And now we've got a body there already that I called head. I'm just going to hide that component for that body for now because I'm going to make a whole different body. I think the way that we're going to start doing this is I am going to create... should we do this with a sphere or should we do this the hard way? Let's do it the hard way. Because then we get to do more stuff. And more stuff is fun. Alright, so I'm going to go ahead and say I'm going to create a sketch. I'm going to draw this sketch on this plane here that is bisecting our scissors in half. Yeah, I'm going to draw on that plane because that plane is like right in the middle of our world here. So it'll probably be handy to have it'll be an easy way to make our halves line up on both sides. So I'm going to create my sketch on that plane there. And I am going to start by using or projecting over some existing geometry. So I'm imagining my scoop as being like this shape up here, right? So, but I'd like to have a line that follows along the same line as our scissor follows. So what I'm going to do is I'm going to click on the Create menu here, and I'm going to come down to Project Include and over to Project. is I want to project some existing geometry over onto this sketch. So I'll go ahead and choose project, and I'm just going to project that bottom line there. That bottom line. And that's just because I want to have a reference for a line that can be parallel to that. And I think our scoop, tennis ball is like 3.5 inches.
Just happened to look it up. It is 2.575 up to 2.7. So call it 2 5/8.
2 5/8 it is. But this line is going to be a little bit longer than 2 5/8 because not all of this is going to be part of the bend mechanism. I'm going to make this a 3-inch line. And then on that 3-inch line, I can create a circle. I'm going to create a 2-point circle. And my 2-point circle is going to go from the end of my 3-inch line, and it's going to have a radius of the size of our tennis ball, which was 2.62 or 2 5/8. Which is good. That fits nicely. And I'm going to hit enter. Now I am going to offset that circle. So this is going to be the inner diameter of our little scoop. If I click create and then come down to offset, is it off? Sorry, modify. My brain doesn't work today either. I'm going to click modify, and then I'm going to choose to offset that line just a good thickness, like 1/8 of an inch will be fine. If this is the thing that we're 3D printing, 1/8 of an inch will be just fine. So either 1/8 or 0.125 is going to be the amount that I offset that. And then the last thing that we need to do here is, so we've got our scoop figured out basically. Here, I'll tell you what, I'm going to extend out. We got a line going on here. This is kind of in the way. That measurement is messing me up there. Let me just move some of these measurements so they're a little bit more legible there. We really want to be bisecting this circle completely in half, because I think we're going to revolve this circle. So if I just grab my line tool and I extend out that 3-inch line just so it encompasses that outer diameter radius of the circle, that way I've got this is the part of the circle that I'm gonna revolve. So we've got the scoop part. We've got part of our scoop. We just need to connect our scoop to our arm here. So in order to do that, I think that I'm just going to, if I use the offset tool again, I can offset that line that we projected. So that line that we projected right at the beginning here, I can offset that and create the thickness that we want to create here. So again, let's make it 1/8 of an inch just to keep things uniform here. So I'll offset it 1/8 of an inch. And then to complete that shape, I'm going to use a 3-point rectangle. So a 3-point rectangle is good when you want to make a rectangle that is at an angle. So you define 2 points. So that kind of represents whatever angle you're going to have your 3-point rectangle at. And then you define a width of the rectangle. So those are your 3 points. And so the reason I offset this line here is now I've got a line that exists at the angle that my arm exists, that I can click on to create my first 2 points. So I'll click on that 3-point rectangle, and I'll make the first line, first point down here. The next point is going to connect to the interior radius of my scoop. And then I'm going to come up 0.75 inches. And then this is our goal shape here that we were making. Can I shift click on all these things so they're easy to see? So now the kind of the functional bits of our sketch are the highlighted bits there. I'll kind of walk around and see how we did.
Oh, sorry,
That's totally cool. Yeah.
I was thinking of something a little bit, are you thinking of eventually going with a spherical pickup cup?
Yes.
Or with 2 fingers?
A spherical.
Okay.
Two hemispheres.
Well, okay. All right, I was thinking of like 2 fingers that
Oh, yeah.
would,
That totally works too. I support your drawings.
and that way you would just eventually, after you extrude one out this way,
Mhm.
one out that way, actually you'd have to do them both ways, but then you would, on your extrude, you would do a join
Oh,
to
sure.
the end of the arm,
Right on.
arm right there.
Cool. Yes, you could totally draw. I will not dictate. It's your drawing. You can make it however you want.
It would be doubly useful, because if you would put a chamfer around it too, it would also be highly useful for medium to small dog poop scooping.
There you go. Yeah, maybe we could invent a thing that puts the
It'll
bag.
scoop it and launch it.
It like has a bag on the scoop.
Yeah, you retract the bag out
And it
over
yeah. All right. That's for future development. I think that's a great idea. All right, so I'm gonna say finish sketch, and now I'm gonna start extruding out my shapes and creating my shapes here. So I'm gonna start by just a basic extrusion. So I'm gonna come into my create menu and choose to extrude out these bits right here, and I'm going to be extruding these. I'm going to choose to extrude this symmetrically, and I know that that's weird because it exists on one side of my mechanism here. So let me show you, like, maybe the thing that you would think we would do here is we would say, hey, let's extrude this 2 sides. Let's extrude it this way, 1/8 of an inch. And let's extrude it the other way, 0.25 inches. And that would, and let's change it from cut to new body. So that would make something that is symmetrical on the arm that we're going to put it on here, right? But the other end of our arm, maybe that doesn't matter. I was just thinking the other end of our arm doesn't really exist at the same plane as this arm. So my tendency, or my first thought, was instead of extruding to each side a different amount, that we would do it symmetrically, and then this would be a body that we could just repeat on the other side. But I suppose we could correct it after the fact. But I think I'm just going to leave it like this. I'm going to roll with the kind of chunky arm there on one side, because when it meets up, that means our hemispheres will match. So I'm going to do that. All right, so I'm just going to say, okay there, we're making this a new body. And I'll tell you what, we've got a hole there. I'm going to go back to my sketch. I'm going to project that hole. And then when I come back into the future here, or back into the present, I can use that. Oh, not that. I can use that as a feature. Now I have a built-in mounting hole. So now this thing, when I 3D print it, will mount on my little laser cut bits really nicely. Alright, so the last thing we need to do to complete our scoop here, or at least the basic shape of our scoop, is I'm going to come to the Create menu, come down to Revolve, and I'm just going to revolve that little end effector shape. I'm going to revolve that too, just to be on the safe side. Now the default here is to revolve things for 360 degrees, and I am only going to revolve it, I think I'm going to go with like 75 degrees, and I'm going to do it symmetrically. So it's not going to, make a full closed hemisphere, but it'll go equally to both sides there, right? And instead of cut, I'm going to choose to join. You know what? I lied. I'm going to choose to make a new body. I suppose if I do choose join, what I have to do is turn off the visibility on my arm. So if I choose join, when I have my arm visible, it'll probably join all three of those bodies together. And the only things that I really want to join together are my little scoop and the little mount for said scoop. So if I have join selected with only those items visible, then when I say join, it doesn't join it to the arm there, which is good. Now I got a body I can name here. This is my scoop. All right. So the next thing we have to do here is I'd like to mirror this over to the other side. So I don't want to have to make this drawing again. I've already drawn the scoop, and the other half I want to look exactly like this. So what I'm going to do here is, I think the method that I'm going to choose is I'm going to create, I'm going to need to create a plane that is right in the middle of our scissor mechanism, right down the middle here, in order to have a mirror plane. And I think the method for doing that, let's turn on my sketch. Let's turn on my sketches here and see what I've got for points here. I've really just got one point in the middle. I wonder if I construct an offset plane, and the plane that I'm going to offset it from is the plane in between my X and my Y location. Sometimes instead of a distance, it'll let you pick an item. So if I just, it doesn't let me do it in that case. What if I pick, is not the
You're trying to make
sketch.
a plane?
Yeah, I'm going to make a plane right in the middle of my scissor mechanism here. And I'm just looking for an easy way to locate that plane based on some existing geometry, which I don't really have. I mean, I can guesstimate it with an offset plane.
It's between the two scissors, right?
Right, but I want that plane to change distance as we change the size of our scissors, so that we're drawing this all parametrically. So I think what I'm going to do here is I'm going to go back to my original drawing, and I'm going to edit the sketch, and I'm going to add another line. Because we want to make this all parametric, so if I decide, here, let me just remind everybody. So we set parameters for the length of each of our arms, the width of the links, and the hole sizes. So let's say, for example, right now, height of rectangle. What is length? I don't remember. This is why you got to have good comments. Height of rectangle. Let's go back to that sketch and figure out. Yeah, so length is 4 here. So if I click modify, change parameters, if I change my length to 8, our scissor just gets bigger, which is cool.
How do you set a parameter?
So in the modify menu and change parameters, you just click the new user parameter button.
And then apply it to...
And then you can just give it a name. So new...
How do you apply it to the sketch?
Instead of typing in... instead of typing in a number...
I saw you do that on the video. Yeah.
Okay, cool. Yeah, instead of typing in a number, you type in something like length.
Length.
Yeah.
Ah, there's your length.
Yeah, exactly.
Cool. Sweet.
All right, so I'm going to add one more line, and the line that I'm going to add here is just going to be a horizontal line. Let's make it 2 inches, because why not? And the only reason for this line to be there is for us to reference as the midpoint later. So I'm going to click on that line, and I'm going to choose to make it a construction line. And I'm going to say finish sketch. So now I've got a line that will always be right in the middle of our scissor mechanism. And I can use it to construct a plane at an angle. Da, 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 da. So I'll choose plane at an angle from our construction menu. I'll pick the line that I just carefully placed and made in there, added to our original sketch like we made it the whole time. See, when they go back and look at our drawing, they'll go, wow, they really thought ahead when they were making this. Look at all these steps that he planned out in advance to make that line. Cool.
It was totally there.
Totally planned out the whole time. All right, so now I'm going to go ahead and click create, and I'm going to create a mirror. I'm going to mirror that body that is my scoop, and I'm going to mirror it over that plane that we just made. And there we go. We got 2 scoops. We're double scooped. However,
You made an ice cream, fancy ice cream.
yeah, really extra long for really getting that ice cream at the bottom of the barrel, at the bottom of the bucket. You know, sometimes you get the 20-gallon tub of ice cream, you know, and you don't want to reach all the way to the bottom. No. So
Multi-tool.
exactly.
Or you could boober scoop.
Yeah, you can pick up the dog poop or your ice cream. You know, like it's up to you. Yeah. You may want to wash in between usage. The problem that we have here is our scoop is in the same component as our top scoop, right? So we've got bodies. Really, this scoop needs to end up in this component, which when I click on it, it is this front 3 here. So I'm just going to take it, and I believe if I just click and drag, I can just drag it. Yeah, I can drag that component or that body into a different component, and now you will see that one is in one component and the other is in the other component.
I have a question.
Yes.
Don't you have to have a handle like on both sides?
I do. In fact, I'm going to do that same trick to fix our handle problem. So I only made one handle in the last class, and now I've got a plane there, so I can grab my mirror tool. I can choose the body that I'm going to mirror, the plane that I'm going to mirror it over, and now I can figure out what component that body actually needs to go in, and it's that one right there.
It was there the whole time.
And there we go. Now I can come back to my main document component. In fact, here, let me just turn off this sketch here. All right, cool. Not bad. Not bad at all. All right, so now is the fun and tedious part. Because there is a fun, tedious part in every project, and this is it.
You mean like sanding?
Yes, this is the sanding of this project. So now we're going to make a ton of joints. Joint production. We're going to
Snoop Dogg.
Revolute them up. They're going to be Revolute joints. All right, so this is going to be, like I said, fun / easy and tedious. There are 2 different kinds of joints that you can make in Fusion 360. There is an as-built joint, and there is a joint. A joint is if you've got your separate components, maybe you brought them in from 2 different documents, and they're not currently aligned where they need to be in order to be a joint. So if you've got 2 bits that are over here, the normal joint option, as part of its operation, first gives you a set of steps where you align the components with each other, and then tells you how to move them. Honestly, I never do that because I just draw my components where they need to be. But like I said, if you're bringing in components from separate files and then you want to make them function with each other, that's why that exists. So the much easier joint to make is this as-built joint, because you're using the joints as you have them built, as they currently, in the positions that they currently live. We are going to make a whole bunch of Revolute joints. So the joint type we have here is going to be Revolute. And there are lots of them. There is a plethora of options. You can make a rigid joint, so joints of 2 things that are going to, stay locked together and not leave each other. There is a sliding joint, so if you've got like a linear track, you can have things that slide on a linear track. The cycloidal joint rotates and slides on an axis. So how is that different than a pin slot? I don't know how this is different than a pin slot joint.
That's like a piston or a pneumatic thing. It's a pin slot.
Oh, rotates and slides the components on a single. Oh, so I guess, yeah, that you're right. That goes up and down. I guess similar to a slider.
Cylindrical does everything. For the pin, what goes pin slot?
Pin slot is it rotates and moves in a slot. So it moves linearly and it rotates as it's moving linearly. And then
Those are pretty much identical.
yeah, plenaire is like X and Y, moves in X and Y axis. And then a ball joint is obviously like a joystick kind of thing. But we are making a Revolute joint. We're making a whole ton of them. And really the only thing the things that I have to do here is I select the two components that I'm going to make the joint with, and then I select what they call a snapping location. This is my only tip for you, is there are these little flags. Pay attention to where the direction that your flags are pointing, and you will be happier with yourself if you make your flags point the same direction. Because that kind of sets up which way is clockwise, which way is positive and which way is negative joint movement. And it'll just be easier if all of your joints are pointed in the same direction,
Okay.
just from your own sanity.
Does that include when you have a setup like this with the scissors joints? Will the middle row of joints be flagged in the same direction as the outside two rows of joints?
I do make them flagged in the same direction.
Okay.
Yeah.
That's a good question.
So you can see it did a little animation there, and it moved, and that's all we want here out of that first joint, right? So now I'm going to click OK here, and I'm just going to systematically do that same thing everywhere I've got a joint. So here's a joint, 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 here's a joint. There's a ton of joints. So I'm going to kind of go along and make these as-built joints just by clicking on one component, clicking on the other component, clicking on my snapping point, and making sure that my flags point the same way. Now you'll notice that when I did this animation on this second joint, edit joint, play. The other joint is just moving irrespectively to it. These animations only know about the joint that you're currently working on. They don't know that other joints exist. So even though you've got a joint that exists that won't let it rotate like that, like for example, I can already click on this first joint, and you know that other thing is attached to it, right? The other arm is attached to it. And even when I do this one, like they're clearly attached. But when you're editing the joint, it doesn't pay attention to other joints that are connected. So, yeah.
Did you know that like you can jump from point to point to point, right click, and a choice comes up, repeat as built joint.
Oh.
Ooh,
Uh,
that sounds like a
Go,
oh yeah, repeat as built joint, and then you click joint input, drive joints. I don't know what that means.
so I did, I just picked out the two. I'm doing all of my middle row joints first, okay?
Okay.
And I go point to point to point, right click, and I just repeat the joint. I grab one
They're
arm,
letting
I
me do it.
grab the other arm, I grab the center point, and I say, okay. And it remembers everything.
All right. Yeah. Okay. So I'm just going to go through as built joint, as built joint, as built joint. Between you and you. Between you and you. Flags are pointed down the whole time. And I'm just going to do this kind of quickly, and then I'll come and take a peek at your joints. Joint inspection. We'll have a joint inspection.
Yeah, I wasn't doing any of that.
Because yeah, this is now.
That could be interesting.
This is what our scissor does. Look at that. Neat. So it goes all the way in there, and then it reaches all the way down.
It's
There.
a snowball maker.
Yeah, there you go.
Oh, yeah.
All right, so I'm gonna hit 0.
Rapid, for rapid fire snowball.
See how your joints are doing.
Why?
I love that.
So far, so good. I don't know.
got a lot of joints.
Yeah.
Actually,
I
okay,
click,
ask him
I
any
right
questions.
click, repeat joint. I pick the one arm. I pick the other arm.
Two very important questions, but I did write them down so I don't forget. Yeah.
We only got one selected. Yeah, you only got one selected there.
Did
No, you don't have any.
Okay, well, let's try it again.
Yeah. There you go, now you got two selected.
Okay, there.
Yeah, nice.
You jinxed me.
Oh, sorry.
Since
No
the
problem.
I have
last
that
time
effect.
I saw you, Carl, I have created two things for other people, and one of them is potentially going to get paid when I am finished,
Nice.
and other is for robotics. So, I have my two very important questions. One, you mentioned something about a 3D scanner.
I think we have one. Tell you what, let me
It's
finish.
totally junk.
Let me finish the class.
Sure.
And then I'll stop the recording, and then then I'll answer questions. Yeah. All right. So once we systematically add all of our joints in, I want to do one last thing to complete this project. So you can see right now, I can move these joints past where is physically possible. You can see I'm transitioning this scissor mechanism through the fourth dimension, where it totally gets all messed up, and you can do all sorts of really weird, trippy stuff here, man. Those joints just became the kind that are only legal in Illinois. So scissor mechanisms will do all sorts of weird stuff. However, this joint here, the joints can have, if we choose to edit the joint, the thing that we skipped over in the joints as we were doing it, you really only need to do this to one of your joints, is you can have a minimum and a maximum degree there. So I can set joint limits. This is actually fairly new in Fusion 360. You used to have to set these joint limits after the fact, and at some point this summer, maybe it was in the spring, they changed it so the joint limits were in the creation of the joint. So now you can set your joint limits right when you're creating them. So if I set a joint limit here between negative 65 and 60, now when I actually actuate this joint, it won't let me go further than 60 degrees this way, which is kind of its, pretty much its limit. And then in the other direction, it won't let me close it more than 60 degrees, which is probably almost as open as it could possibly be anyway.
Okay, Carl.
Yeah.
I have a question here.
Yeah.
On this one particular joint, it is not letting me put my hole-in-one flag where I want, okay?
Mm-hmm.
All of the others are down facing left, okay?
Mm-hmm.
This one right here, no matter what I do, it will not let me do that.
Try looking a little bit more three-dimensionally. Try moving your navigation cubes and kind of look. Yeah. Sometimes if you choose like the edge of the circle, there we go.
Okay.
Yeah. I'll also say this is a good practice. I think that this is a good practice to make your joints move have them be facing the same direction. But in this particular case, it doesn't really matter. Where it matters is I've got like 2 gears, and this gear has got to connect to this gear, and when this gear moves positively, This one is moving the opposite direction, so it's moving negatively, and it just makes more sense when you're looking at two things that you know need to move opposite when the numbers reflect that they're actually moving opposite. If the flags were pointed in opposite directions, it could be that even though your gears are moving
Because we don't want
opposed to each other, they're both moving in negative direction or they're both moving in positive direction because those flags are pointed in different directions. So this is just a good practice here. In reality, one joint is driving all of these joints because they're all connected. But
because we don't want to create something that's going to grind and get destroyed as soon as we make it.
right. All right, cool. I'm going to add a little bit of color here just in the last couple of minutes.
Already we talked about.
So I'm going to find my plastic. I'm going to come down to transparent. I'm gonna make these bits out of laser cut transparent acrylic. In fact, I've already laser cut my bits. I just need to assemble them. And then I've got white plastic that I'm 3D printing with, so I'll drag out some white plastic on my pinchers and on my mechanism.
That actually looks really cool.
And there we go. We got a scooper. For scooping the bottom of the ice cream. It probably would not be sufficient to scoop ice cream because, ice cream is cold and super hard. But you can definitely pick up a tennis ball off the ground and not have to bend over.
I just think the end of it looks a lot like a ice cream scooper.
Yeah,
There's
yeah.
That little round part that goes in the middle.
Yeah, it is scooper-esque for sure. All right, cool. So that is it for today, and I will see you next week.